Hey everyone, in this video together we will build a three-tier architecture on Amazon Web Services. This architecture is one of the most popular application architecture, and yeah, let's jump into it. So the application is split into three logical tiers. This include a presentation tier. So this is the user interface that allows people to interact with the application. It's typically designed for a use on personal computer or mobile device, and it's built using HTML, CSS, and JavaScript. The application tier, this is the logic tier that sits between the presentation and the database, and it's responsible for communicating between the two. So any information gathered through the web tier is processed in detail in this tier, and it also interacts with the database where data is stored. Uh, the tier is developed using languages like Java, Python, PHP, etc. And finally, the database tier. So this is the component that stores and processes data, and it's typically built using a database management system. You can observe the three tier of application architecture in this design image below. And this architecture really offers great benefits to the organization when building application infrastructure. These benefits include scalability, so it allows organization to scale each tier independently depending on the workload, and this is particularly useful for organization with any unpredictable workloads. Reliability, so by separating the different tiers of the application into separate servers, an organization can improve the reliability of the overall system. So if one tier experience an issue, the other tier can continue to function, reducing the downtime. Security, also improving security by separating the different parts of the application into different servers, and this really can help to reduce the risk of a security breach or data leak. And we have cost efficiency. So a three-tier architecture can be more cost efficient than a single monolithic application because the organization can choose to use less expensive resources for certain tiers and only allocate more expensive resources to the tier that requires them. We will do a demo for this architecture, and all you need to know to follow along is an AWS account and access to the command line interface CLI. Um, for our use case, you are a cloud engineer for an X organization and have been asked to design and create a highly available three-tier architecture for the company new web application. So the web server handles incoming requests from the customers. The application server will process the request and retrieve data from the database, and the database server will store all of the product and customer information. The benefits from this is by creating their architecture and separating the different tiers, the company can scale each tier independently to handle the workload, improve reliability, enhance security, and optimize cost. Just a quick reminder, please remember to delete all the resources created and configured when you are done following the steps of this tutorial. We have NAT gateways, Elastic IP, and ELBs that have small costs, so please ensure to delete them later on. All right, so let's jump into it. And the first thing we will do is to build the VPC. All right, so the first step is to build the VPC. We'll go to the VPC service in the AWS account, click Create VPC. We'll choose VPC and more to configure the VPC, the subnet, and other networking services at the same time. All right, so we'll choose a name for our VPC. Let's say VPC 3 tier. I will leave the IPv4 CIDR block as 10.0.0.0.16. We don't need IPv6, so we'll continue. We'll choose two availability zones for high availability, which will host our subnets. We will also choose two public subnets. So two public subnets. to host our web tier, which will need public access and four private subnets um, to secure our backend resources. Okay, and then for the NAT gateway, we will need a one NAT gateway in one AZ, and we don't need VPC endpoints. And yeah, this is as you can see it now. So two public, four private. We have the route tables here, and we are good to go. So create, and we just need to wait so everything gets created and configured correctly to our VPC and our specific configuration. Just gonna take a couple times here. All right, as you can see, everything has been created. Just need view VPC. All right, so this is our VPC tier VPC. Let's go to the subnet. We'll select for VPC. Okay. Okay, so as we have all the subnets, route tables, and network connection has been created, we have to go into the public subnets and enable the auto assign public IPv4. So the first subnet is this one. So go to action, edit subnet settings, and enable auto assign public IPv4. So the subnet will be publicly accessible through the internet. And save it. This is done, and go to the second subnet. Action, edit subnet, and same thing. Save. Alright, so this is private, this is public. So we have an IPv4 for this one and an IPv4 for this one too. So yeah, now that we have configured our VPC, subnet, and other network services, we can proceed to the other step. So after we have successfully built the VPC, the second thing we will do is build the web tier. All right, after creating the VPC, let's build the web tier. First thing, let's go to the EC2 dashboard, and we will try to launch an EC2 instance from the autoscaling group. So we will have to navigate here to the autoscaling group, create autoscaling, give it a name, web tier, autoscaling group, and we need to create a launch template, web tier launch template. We'll choose the AMI, the free tier eligible, this one. And for the instance type, we'll choose T2 micro. Probably need a new key pair tier. So after that, we need to create a new security group. We'll give it a name, web tier security group SG. Description probably say web tier SSH and HTTP access, as we need to give access to like we need to define inbound security group rules to allow SSH, HTTP, and HTTPS access to our public-facing EC2 instance from anywhere. So first rule would be SSH anywhere. Second one would be HTTP from anywhere too. And third one would be HTTPS from anywhere. And we will leave the rest of the options default, and we have to scroll down all the way to the bottom, advanced details, and we will define some user data. So this is a script that would be included in the launch template. So every time a new instance would be spin up with this script, so we don't have like to um, do this manually every time a new instance is created. So bean bash. So the first thing is to do is to update all em package repositories by doing yum and update -y. Second one would be install Apache web server. So yum install -y httpd x86. This would be the architecture of the web server, and we will need to start and enable Apache web server. So systemctl start httpd service and systemctl enable httpd typo service. And last thing to do is to add our custom web page HTML code to the index.html. file. So echo HTML. So this will be like an HTML code to just define something like hello world. We'll close the H1, then we'll close the body and HTML. Okay, and then we will forward this code to var www html slash index.html. Alright, so this is done. Create the launch template. Wait for this. Launch template is created. If we refresh this, we will have our launch template here. Okay, this is good. Next, have to make sure to select our VPC. For the availability zones, we have to select the two public subnets, public 1 and public 2. So this is good. So click on next. We need to attach a new load balancer. Would be an ELB. So I'll probably give it the name WebTier LB. Has to be internet facing, of course. We need to make sure this is public and this is public. Amazing. Okay, we need to create a new target group, WebTier LB. And probably enable the group metrics collection. So yeah, just to allow the collection of information for our autoscan group to be collected in CloudWatch. Yeah, just click on next. Let's just put target group. Okay, desired capacity, probably do 2. Scaling limits, this would be target tracking. Minimum would be 2, maximum would be 5. We'll probably scale on average CPU utilization, probably like put it like as 50 here. Yeah, click on next, next, no tags, just a quick review here. Alright, good to go. Create auto scaling group. So the auto scan group should be created, and we just need to wait for a few minutes for it to update the capacity and create the new EC2 instance. So once this is done, we will check our instances. All right, so we have our EC2 instance being spin out from the autoscan group, and they are in a running state. If we go to the load balancer, it's active. We need to copy the DNS name and just come here, and yeah, as you can see, hello world. This is from the load balancer web tier. So yeah, we have successfully created the web tier, and now we can proceed to the next step. So with that being done, third step is to build the application tier. All right, so for the application tier, we will create another autoscan group to launch the EC2 instance into private subnet that will allow inbound traffic across from the web tier. Just a quick note, this is not a true application tier as we don't have any provided code to run on the EC2 instance. So yeah, just navigate to the EC2 dashboard and go to the autoscaling group. Create a new autoscaling group. So this would be app tier ESG, new template, app tier launch template, and we will choose the AMI and T2 micro for this. Probably use the same key pair. Create a new security group, so this would be app tier security group, and this is to allow SSH access and ping from web tier, and we have to make sure to use the right VPC, add inbound SSH, and the source would be from the web tier security group. Okay, this would be it. Launch template. Alright, this is being created, so we have to refresh this, and yeah, this is it. Go to next. So choose the VPC. For the availability zone and subnet, we'll choose the private one and private 2. Private 2. So go next. We will obviously attach a new load balancer, ELB. This would be app tier load balancer, and this would be internal, no, not internet faced, as this is gonna be the in the private subnet. So make sure this is private and this is private. Okay, this is good, and we'll have to create a new target group, app target group. We'll probably scroll down here again and enable group metrics. Yeah, click on next. Desired capacity, probably do 2 here, minimum 2, maximum 5. Probably scale based on CPU, average CPU 50. And that's about it. Next, quick review here. Okay, looks good. And then create. So we probably should wait for a few minutes here till the capacity be updated. Another thing to know that I forgot to allow for another security group rule for the ping. So we need to choose that here. We can always edit this in the security group section and just add the rule, save it, and we should be good. Okay, our two EC2 instances are launched and they are being initialized. Alright, so as our all the EC2 instances are spin up and they are running, we need to verify the connectivity between the two tier by pinging the application tier from the web tier. So we can achieve this by connecting through SSH to an EC2 instance in the web tier using the public IPv4 address, then run the command ping to a private IPv4 of an EC2 instance in an application tier. So to do that, I'm going to select this EC2 instance, which is from the web tier, connect. So to do the SSH client, I'll open a terminal here and copy this. Okay, so and then we will probably just connect to it. Yes. Yeah, we connected. And we probably do ping. So this is the command ping, and we will have to go check the IPv4 of an application tier. So this is web tier. This is from the application tier, and have this. Yeah, as you can see, the ping is working. We receive response, so the connectivity is working here. Yeah, so I'm just gonna cancel here. So now we have determined that we can reach our private IP. Alright, now let's move on to build the database tier. We will create an MySQL database in a private subnet for our application tier to connect and interact with. We'll have to navigate to the RDS dashboard. We'll have to create on these subnet groups and create DB subnet group. So the name would be DB subnet group, description DB sub group here. Of course, we need to make sure to select the right VPC. For the availability zone, we will choose US East 1A and B. And for the subnet, we probably need to make sure to use the two other private subnets. So I'm just gonna quickly go back to verify what subnets are not being used. So there's the subnet. So this is private one, and this is private 2, so we'll probably use private 3 and 4. ABC. Okay, 3 There's a three. So there's a three. Let's check the 4 ADZ0. This one. All right. So with this being set up, create. Okay. Okay, let's go back to the dashboard, databases, and let's create a database. So standard create, we'll probably choose MySQL, MySQL community. Yeah, probably use this engine version for the template. We'll probably use dev test to select multi-AZDB instance, but we can choose free tier. Multi-AZ. Alright, settings. So DB identify database 1, admin. Let's do self-managed. We probably do just like a sample. Okay. We don't really need, connectivity. Just need to make sure that is in the VPC. Subnet group. This is the subnet group that we have created, and no public access. We probably need to create a new security group. So DB tier security group. Yeah, that's it. We probably just create a database. Oh, okay. We'll probably just like do a free tier. We don't need to do AZ. Okay, now the database is being created. Okay, the IP should be the security have to be in the application tier security group. has been created, MySQL. Okay, from the application tier. So yeah, the database must be created here. It's creating, and the security group has been modified. So we can allow the rules to, so we can allow the application tier to connect to the database through the port 3306. All right, so now we have completed tiering through the clouds, and you have successfully built a three-tier architecture in AWS using the management console. I'm aware that this involves a lot of clicking and configuration to set up the infrastructure. On the bright side, it's possible to have this whole process automated using infrastructure as code. We have two amazing tools, Terraform and CloudFormation, AWS CloudFormation. However, it's very beneficial to go through this procedure so we can get like a fundamental understanding of how all the components work and fit together. And that's it. Thank you.